right, let me just see here. Okay, awesome. Well, thanks for having me again, and I'm here today with Simone, who you haven't met yet. Yeah, like we were saying on Tuesday, I actually enjoyed some of the questions that you guys shared. So I'm trying to post and answer every day or something around that range. I think if that's okay with you, I can maybe share my screen and we start introducing DePIN a little bit, what IoTeX is doing, and then I'll pass the ball to Simone, who is going to basically show all the components of like a DePIN application in more detail and basically run this workshop on how to build like an end-to-end application, and then maybe we do some Q&A afterwards. Does that sound good to you guys?
Yes, yes.
Awesome. Okay, so I'll go ahead and share. Here. Okay, I think you guys should be able to see this now, right?
Yeah.
Awesome. So I'm just gonna go away and present. And I think you guys can see, right?
Yeah. Yes.
Awesome. Sweet. So again, thanks TinTinLand for having us. My name is Giuseppe, and with Simone, we're part of the DevRel team at IoTeX. If you want to follow us to learn more about what we're doing every day, besides like the official IoTeX channels, Simone is Zimne and I'm DePIN Jesus, and we also run the IoTeX Dev account, where we normally just focus a little bit more on the technical content. So for developers, builders, or maybe enthusiasts that just want to know a little bit more like how or what happens behind the scenes in a DePIN application. All right, so I wanted to quickly introduce IoTeX and what IoTeX does. IoTeX provides a modular infrastructure to build DePIN applications, just like we talked on Tuesday. So what does that mean? It means that basically, as we will see in a few minutes, DePIN applications has various components, and IoTeX provides a sort of like a cohesive infrastructure that puts all these components together. And some of these components are provided by like third parties, and some of these components are provided by IoTeX in-house. And the most critical components of a DePIN applications provided by IoTeX are the DePIN blockchain. That's the IoTeX layer 1, which is a super fast EVM type of blockchain. We have a TPS of max TPS of 1000, which is great. We have full Ethereum compatibility, and we have instant finality, 5-second block time, and I think we have passed the 100 million transactions a while back. So the IoTeX layer 1 is fantastic for DePIN. We have another infrastructure components that's called IOID. That is a protocol to manage the DePIN identities, which means basically the identities of like the machines involved in a DePIN network, the devices, the owners, so the contributors to this DePIN network, as well as the identities of basically a project as a whole within the infrastructure. And then we do another component that is called WebStream, and that basically handles the verification of DePIN. Because as we will see in just a few minutes, DePIN verification ends up being one of the most crucial components of an application, and we'll find out why in just a second, even though we brushed upon it on Tuesday. So I've introduced DePIN on Tuesday, but let's just do a little refresher for everybody that maybe hears this word for the first time or maybe is not too familiar with it. As you can see from this slide, there are a ton of applications that are involved into the DePIN landscape. DePIN stands for Decentralized Physical Infrastructure Networks, and it is essentially a special set of applications that facilitate a token economy for basically for people or participants to provide infrastructure and run an infrastructure And this token economy basically incentivizes people to do so. So there are two main parts in a DePIN application. One is the off-chain infrastructure, physical infrastructure part, and one is the on-chain token incentives and business logic. Now, one of the coolest things about DePIN is that finally it's basically putting together the physical world and the on-chain world, which is great because we're seeing a lot of like these real world based applications that are just like beyond just the world of Web3. So we're not like siloed in our own Web3 world anymore, but we actually can build applications that provide some like real world utility. And that is fantastic because I think it's basically one of the ways that finally Web3 is opening up to the general public and to mass adoption, which is great. So that is great. At the same time, this sort of like physical, real life, and blockchain type of dynamic in a DePIN projects also represents a huge issue in a way, because essentially, how do you trust that something, and I brushed upon this on Tuesday as well. So how do you trust something that comes from the physical world to trigger some sort of like financial incentives on the blockchain? And when we were talking about this on Tuesday, if you think about it, like when you have like DeFi applications, for example, you basically, everything is on chain. So everything is like trustless, and everything can be sort of like checked on chain. But when you talk about DePIN, how do you make it so that the physical world can somehow be verified, and this data can be verifiable by smart contracts that's on chain to trigger like a financial incentive? And especially when you add financial incentive to this data, then obviously that becomes one more reason to try to spoof the network in any way. I forgot to say one thing. So if we go back here, just to give you an idea, right, to understand more DePIN, perfect, the most maybe famous example of a DePIN application is Helium. And Helium, basically, it's a physical infrastructure of like these routers that provide connectivity. So they provide a service for end users. And the people that run these routers are rewarded on chain with like, the Helium token. And like Helium, we've seen other large applications like Demo, for example, that's in the mobility sector, various weather-based applications like WeatherXM, for example, where basically people are rewarded to provide data through these devices within the network. And so what I was saying earlier is like, how do you make it so that like, an on-chain, basically smart contract can trust like the physical world? Normally, the way it's done basically almost in every case at the moment is done through a centralized cloud backend. So what does that mean? It means that if you look at this slide, on the left side, you have this like network of physical devices. On the right side, you have these like smart contracts that basically, and like these tokens that are used to like reward data contribution. And then, so these are sort of like the two decentralized parts on the opposite side of the spectrum. And then in the middle, all applications at the moment basically orchestrate this communication and orchestrate this business logic within a cloud infrastructure. And obviously, while that is okay to like begin with, it poses various problems. Like DePIN applications are not really composable at the moment. They're not really trustless, but you really have to trust the single entity that runs like, a certain DePIN project. And it's hard to also have these applications be interoperable, meaning like basically talking to each other in any way. So each DePIN is sort of like siloed at the moment. So the point of IoTeX is to actually decentralize this central part here, this cloud backend part, and propose these basically 9 layers to decentralize the whole stack. If you look at this slide and you think about basically data, let's say, coming in from the top of the slide, from your devices, then we identified and provide this like hardware abstraction layer that connects with like this connectivity layer, sequencing to pack all this data together, store it in some sort of like data availability layer, have this data being computed in an off-chain computing network that does basically verifiable computation, and Simone will dive into that in more detail in just a sec, and then finally orchestrate the token rewards on-chain and issue these transfers. And then on the left, you see these like two vertical sort of like protocols that basically are used throughout the whole pipeline. And one is the identity protocol that I was talking about earlier, and like a governance layer in case of like, DAOs or decentralized basically communities and things like that. So what I'm going to pass the ball to Simone now. And what Simone is going to talk about is basically how do you spin up these like services, and is essentially going to focus more on the identity part, on the off-chain computing part, and then on the blockchain layer where we'll have some smart contracts that basically puts everything together. So I'm going to stop here. I'll stop sharing, and I think, Simone, it's all yours now. Also, I don't know if there are maybe questions about what I just talked about, or maybe we do them towards the end.
Yeah, we can do this towards the end if there are
towards the
questions.
end. Okay, cool. Yeah. All right, Tracy, all good.
Can you see my screen?
Yes.
Okay, cool. Yeah. Hi, everyone. Thank you for joining this workshop. Yeah, Giuseppe took you through a high-level introduction to IoTeX and what is a DePIN, what are the challenges of DePINs, and why. Actually, let's focus a little bit more on why we need all these layers to create a DePIN application. So as Giuseppe said already, when the main problem of a DePIN is how your DePIN smart contract, your DApp, who is supposed to incentivize people to deploy and maintain an infrastructure in the physical world, how this DApp can trust what's happening in the physical world and actually confidently distribute these rewards on chain to the actual owners of the infrastructure nodes based on how they are maintaining this infrastructure and how much work their part of the infrastructure is doing in the physical world. So usually the easiest way would be to just have a cloud infrastructure, typically an IoT system that runs on a cloud where all the devices that make up the infrastructure are connected to this cloud, sending data to this cloud, and then the cloud would just manage everything off chain, and the smart contract would just trust that cloud server to trigger whatever rewards to whoever the cloud says it should be distributed. So obvious problems of this implementation, that's how basically any DePIN project is implemented today. The main problems are that this implementation is not a Web3 application. It's basically a Web2 system that, of course, is not trusted. And, of course, it's not composable with other on-chain applications, for example, DeFi applications, right? So how can you do it without having a cloud? Basically, you have to decentralize all the services that these cloud systems are providing for the DePIN application. And these services can be identified for a DePIN project into, we have identified these like layers to like decompose the centralized like services into a decentralized infrastructure. So starting from the hardware layer, you have a hardware layer that interacts with the hardware itself. So that's what is typically called the firmware part, and it's more IoT development, right? And then you have some hardware. Think of typical DePIN application as an example. For example, Helium, or I don't know, Demo, or any, let's say, a decentralized Wi-Fi infrastructure that is incentivized by the blockchain. Usually the hardware is a Wi-Fi access point that people are incentivized to deploy, connect, and provide Wi-Fi service, and then get rewards on chain. So you have this hardware piece of the infrastructure that communicates some information about the service that it's providing to the users. For example, could be, okay, I am this device X, Y, Z, right? And today I've provided, I don't know, so much network coverage, so many, I've served so many clients for so long time, whatever, right? Providing this information should make its way up to the smart contract to decide how much and if the owner of this Wi-Fi access point should be rewarded. So this device is typically going through some connectivity, for example, HTTP or MQTT, to send this data to a server. So this server we call it a sequencer. The sequencer is typically the service that receives the data from the device and does some validation. For example, authenticates the device, validates the data to see if it's consistent, if it I don't know if the quality of the data is right. And then it packs together these data messages in a data block and places this data block somewhere. We call this next layer, a data availability layer, right? And that's where like these data blocks are stored before they can get processed by the next layer that we call the off-chain computing layer, which fundamentally fetches the data blocks from the DA layer, the data availability layer, and process this data to somehow identify what the devices are doing, right? So if they are working correctly based on the data that they produce, if they're working correctly, if, I don't know, whatever like DePIN logic you want to run on top of the device data. And finally, the main role of this layer is to generate a cryptographically verifiable proof of what happened in the physical world to these devices, basically what these devices are doing. Generating a single proof on top of an entire block of data also allows for data scalability for a DePIN application. So the data don't have to make their way directly into the smart contract. That would be not scalable for a blockchain. Instead, they get packed and computed off-chain by an off-chain computing layer that generates a single verifiable proof that goes to the blockchain. And then on the blockchain, your DePIN DApp contract would just have to verify this proof and then process whatever the output is of the off-chain computing layer, for example, to distribute incentive rewards to the owners of the devices that actually behaved correctly in the physical world. All these layers should be decentralized. Not all of them today are decentralized because the Web3 technology is still progressing into the research aspect of how to decentralize the connectivity, how to decentralize the sequencing, how to decentralize data availability. For some of these layers, there exist decentralized networks. For some others, there are no options, not decentralized options to date. However, it's possible to decentralize many aspects of a DePIN project. So yeah, let's get a little bit more into the details of how you would design a DePIN proof of concept, yeah, let's say. So how these layers translate in an actual architecture for a possible proof of concept for a DePIN application. So, let me clarify that the time is not enough to implement a working DePIN project, of course, in 45 minutes. If it would be so easy, right? There would be a lot more DePIN projects decentralized out there, but we can focus on some crucial aspects, right? I'm assuming that many of you are already Web3 developers, so they know how to create and deploy a smart contract on chain. So these are the two parts of a DePIN project. You have a non-chain, a blockchain part of your application. I colored in green all the components of the DePIN project, and in light blue all the components of WebStream, which is one product, one infrastructure that we provide. And and this purple pink color represents IOID, which is another infrastructure that we provide. And I'm assuming that the blockchain is, of course, the IoTeX blockchain. So let's go through this architecture, simulating how it would work, right? So you have a physical infrastructure that's the lower part of this architecture, where you see all these devices. These devices could be whatever infrastructure you are trying to incentivize, right, or to decentralize with on-chain incentives. So if it's a decentralized Wi-Fi or a cellular network, this would be Wi-Fi access points, or could be 5G antennas, or could be weather stations in a weather data infrastructure, or could be, I don't know, autonomous cars, autonomous drones, whatever type of utility you want to provide with this infrastructure. The device will change accordingly, right? But regardless of what the device is, this device is communicating some data to your application, or at least should provide enough data to prove to your smart contract what is happening in the physical world, enough to be able to distribute rewards, or even more data if your on-chain DApp needs more data to, I don't know, if it's a game, I don't know, or if it's whatever financial application, right? Any additional data should be sent out from the device. This data is going to, in this case, it's just a service that, because there are no decentralized data sequencing infrastructures out there so far, not specifically for DePIN, right? There are some for scaling EVM blockchains, but these are very specific use cases that do not apply to DePIN. So assuming this one is going to be a service that you can create, and we provide some examples, implementations. So the role of this service is going to be to receive the data from the device and pack this data in what we call a WebStream task. A WebStream task is basically a block of data with some metadata inside. And so this block of data is then stored into a DA layer. So there are multiple options for DA layers out there, decentralized DA layers out there. However, for a proof of concept, we are going to use a simple Postgres database that is publicly accessible from WebStream, right? So let's say that the data streaming and sequencing and data layer basically are implementing these two connectivity and sequencing, right? And Postgres is providing the DA layer. So next, we need something to act as an off-chain computing layer. So something that can process the data blocks to generate a proof for our DApp depending on whatever we want to prove to our application. So for this type of service, we built WebStream, which is a decentralized off-chain verifiable computing that is based on zero-knowledge cryptographic schemes. Not sure how many of you are familiar with zero-knowledge proof generation. There are different frameworks to basically compute some data and generate a cryptographic, let's call it signature, right? Or more generically, cryptographic proof that proves the computation that has been performed on the input data, and additionally generate some output. So basically proving that output has been actually generated by a certain set of input with a specific algorithm. So this is what a zero knowledge like framework can provide. WebStream allows you to deploy these ZK logics to a decentralized network of prover nodes and use it into your DePIN application to compute on top of the data from your devices and generate a proof for your smart contract to distribute rewards or to run whatever on-chain logic it's supposed to run. So typically the flow is that your device sends data to the streaming and sequencing layer. The streaming and sequencing layer validates the data, packs them into a data block and stores the data block on the data availability layer. In our case, it's a Postgres database. Then WebStream would fetch every new block of data, pass it to your proving ZK proving logic, and send back the ZK proof. Well, actually not to the DA layer, that's a little bit confusing here, but eventually it's sending the ZK proof to the blockchain. So it's not sending it to your DApp yet, it's sending it to WebStream on-chain contracts that will do some more like logistic on the proof, verifying the node who generated the proof, and some like WebStream, token economy. And then eventually the WebStream router contract would send this ZK proof plus the metadata to your smart contract. And typically your smart contract would verify the proof, access some like identities on chain, and then finally distribute some incentives. So yeah, as I anticipated, while it's possible to build a DePIN proof of concept quickly if you have a good tutorial, it's anyway made of many components, and you should understand all the components that make this like design, this architecture. So today I'm just going to focus on like this off-chain part and just give a quick look at a possible DePIN DApp contract, how it would work. I will very lightly like go through the identity part, but you're totally like invited to check out our documentation and join our Discord to start building something and ask questions and seek for help, because anyway, this is all a little bit in development, in beta, and yeah, any contribution is also welcome.